everybody is enjoying whatever day of the week it is when you're watching this. We're moving on. We're going to jump kind of a chapter into chapter 8 here for just a day or two, or just a day actually. Today we're going to talk about the law of sines and the law of cosines. So we've been finding missing sides of right triangles and missing angles of right triangles and those different types of things. So today what we're going to look at is what happens if they're not right triangles. Can we go about and find missing sides and missing angles? And there are two laws that we are going to use in order to help us do this. The law of sine and the law of cosines. Now, the law of sine and law of cosines allow us to use trigonometric functions to non-right triangles. Given triangle ABC with angles capital A, capital B, capital C, and opposite side lengths of A, B, and C. So if we're given certain parameters, we can find missing sides and missing angles of triangles. We have to be given specific things in order to do this. And there are some cases where there's what's called an ambiguous case. And we're not going to talk about the ambiguous cases in this course. That's something that you'll talk about in pre-calc. But know that there are some different types of triangles that you may have a couple different answers for those. And those are called ambiguous cases. And we're going to talk about those in here. But we are going to look at several different examples of things to do. So the first one's the law of sine. We're going to use the law of sine when you need to know three things for either of these to work. The law of sine we're going to use if we know the measure of an angle and the length of its opposite side, and then one other thing. But in order to use the law of sines, we at least have to have the measure of an angle and the length of its opposite side. If you don't have that, you can't use the law of sine. And you also need one other thing. So the law of sine says that if I take the sine ratio of angle A over side length A, that's equal to the sine ratio B over B, which is equal to the sine ratio C over side C. And so the law of sine. So essentially what we need to have is we need to know the measure of the angle and the length of its opposite side, and then we need to know one more thing. Maybe we're given that we know, what B is, or measure of angle B. If we know what the measure of angle B is, then we can find side B using the law of sine. If we know what side C is, we can find the measure of angle C. We don't have to use all three ratios. We're just going to use two of the ratios to do this. And then once we find one thing, we could solve the rest of the triangle if we want to do those things. But at the minimum you have to have is you have to have the measure of an angle and the length of its opposite side plus one more thing in order to use the law of sines. So that's the law of sines. Sorry about that. Law of cosine. With the law of cosine, essentially you need three things again. You either have to have like side angle side or side side side. And either of those things work, then you can find and use the law of sines. And really, these formulas all say the same thing. The law of cosine says that the length of side A squared is equal to the length of side B squared plus C squared minus 2 times B times C times the cosine of A. Okay, sounds confusing, and it can be a little bit confusing, especially when they put all three of them. But understand that it's essentially the side squared, and it doesn't matter which side you pick. It could be either of those sides. It's that side squared is equal to this side squared plus this side squared minus 2 times B times C times the cosine of angle A. And again, I can move these blue dots around. We could say if you're given B, that B is equal to A squared plus C squared minus 2AC times the cosine of B. It's all dependent on what you're given, and you just kind of have to remember the opposite side the side that you're trying to find, that's what everything else is going to equal to, if that's what you're trying to find. So that's the law of sine and that's the law of cosine, and we're going to obviously use those quite heavily coming up, in the following examples. So we're going to start looking at some examples of the law of sine. A lot of times, these can be kind of your story type problems. They don't have to be, but they certainly can be. So in this example, it says Nicholas is walking along an obstacle course that begins at point X. He starts going straight on the path, then he takes a wide right turn onto a second path at point Y and continues for 1,000 feet before turning onto the final path at point Z. What is the angle between the second path and the final path, point Z, and round to the nearest degree? Okay, so I'm going to just draw this triangle outside of, they've got it drawn there, and it's a nice drawing, but sometimes it's easier just to kind of see it here. So they tell us that this is 1,000. The measure of this angle right here is 32. This is 1,200. And this is essentially the measure of the angle that we have to find. And they've got it labeled, there's my X, there's my Y, there's my Z, and they tell us it's not drawn to scale. So I'm going to identify what I have. And when I identify what I have an angle and two sides. Well, you'll notice that the side and that 32, the measure of our angle, is opposite the 1,000. So right there, law of sine. Tells us that we're going to use the law of sine. So the law of sine says the sine of the angle that we know, the sine of 32 over the length of its opposite side. Lengths are always on the bottom, angles are always on the top. That's going to equal the sine of theta or z or whatever, I put a theta there, the sine of z over the length of its opposite side, which is 1,200. Okay, so we're trying to find the measure of an angle. Okay, so kind of keep that in mind. We're going to cross multiply. So when we cross multiply here, we're going to take the sine of 32 times 1,200, or 1,200 times the sine of 32. That's going to equal 1,000 times the sine of theta. So we're going to divide both sides by 1,000. Because essentially we have to figure out what that is. So we're going to break into our calculators. We're going to go 1,200 times the sine of 32. At this point, I like to hit equals. You probably don't have to. And you're going to divide that by 1,000. So you're going to get a decimal point now. So you're going to get 0.6359. And just leave it in your calculator. Don't take it out of your calculator. That's going to equal the sine of theta. But now remember, we're trying to find the measure of an angle. And when we found measures of angles with right triangles, we did the inverse. So that's what we have to do. So we're going to hit second sine, because it's the law of sine. And then in your calculators, you can just hit second and then hit the negative key down there. And answer will plop in there. So we find out when we do that we get a measure of an angle. It says round to the nearest tenth of 39.5 degrees is what that angle is. Okay? And we're done. Now we could figure out the rest of the triangle if we wanted to. And we could figure out the distance. We could figure out, angle Y pretty easily. They have to add up to 180. And then we could find the length of that missing side as well. We're not going to do that, but we certainly could do that if we wanted to. So there's one example of the law of sine where you're trying to find the measure of an angle. Let's look at another one. In this case, Amaya is flying a Zeppelin balloon. The string is 90 feet long, so we've got our 90s right there. Has an angle of elevation, so remember we talked about that yesterday, it's parallel to the ground and up of 60 degrees. That's right there. Across the park, Rochelle is watching the balloon, which is between Rochelle and Amaya. The angle of elevation of Rochelle is 75 feet, or 75 degrees. It wants to know how far apart those two are standing and round to the nearest foot. So it wants to know this part right there. So it wants to know how far apart they are. So again, we look at what we have. We have the measure of an angle and the length of its opposite side. So right there, it kind of tells us we have to use the law of sine. And we have the measure of another angle, but I'm not trying to find the length of that opposite side. So that means if I can find angle K, I want to find angle K. Well, they have to add up to 180 degrees. So 180 minus 75 minus 60 is going to give us the measure of that angle. And we find out the measure of that angle is 45 degrees. Okay, so we've got it set up now. So kind of my first ratio that I always like to write down is the ratio of the length, measure of the angle that I know. So the sine is 75 over 90. The length of the measure of the angle over the opposite side is equal to the sine of 45 over x. So this time we're trying to find the value of x. So again, we're going to cross multiply. So 90 times the sine of 45 is going to equal x times the sine of 75. So we'll go ahead and divide this by the sine of 75, both sides. Get out the calculator. 90 times sine of 45. Again, I like to hit enter. Divided by the sine of 75. And you get, they are 65.9 feet apart. So that's 65.9. And it makes sense. Opposite the 75-degree angle was 90 feet, so opposite the 45 should be less than it, and it is. So we found it. Like the missing side. Again, we could find the other angle. We could find if Rochelle was holding up a string, we could find that. We could find this if we wanted to, and I want to. So I'm not going to. Right. Let's look at another one. Okay, so I'm going to have you do these two. Essentially, you're going to be asked to solve the triangle. So you're given NPQ. The measure of angle N is 105, side N is 12, P is 10. You need to find angle Q for part A, and then for part B, find the length of side Q and round to the nearest tenth. Okay, so you can go ahead and press pause. Be back in a couple seconds, and the answer will appear. in 3, 2, 1, go. All right, so there's your solution. So in this case, you did have to go ahead and find something that you may not have needed initially to get to your answer, but you had to get it to get to your answer. So we had to find the measure of angle P first, because that's the only, we knew the opposite side of P. So we had to find P first. So I found P first, angle P anyway, and I found that's 54 degrees. And then once I found that was 54 degrees, then Q is going to be 180 minus 105 minus 54, so 21. So now that I have that, they asked me to find side Q, so I can just use my sine ratio of 105 over 12 again, and now that's going to equal the sine ratio of 21 over Q. Go ahead and solve that, and you get Q is equal to 4.5. Okay. So there is the law of sine. The next thing we're going to look at is we're going to look at the law of cosine. How can I tell that this one example is the law of cosine instead of the law of sine? You kind of look what you have. And when I look what I have in this case, I have 9, 65, and 17. I don't know the measure of the opposite side of my given angle. And since I don't know that, that means that I have to use the law of cosine in order to do this problem. So, look back in your notes for the formula. Essentially what the law of cosine says, is that the side of my known angle, so I know measure of 65, the opposite side of that is t. So the formula says that t squared has to equal the two sides that make up our given angle squared, so 9 squared plus 17 squared, minus 2 times 9 times 7, and then this is the law of cosine, so it's going to be then the cosine of 65. Now my suggestion to you when you're solving this, punch in your calculator exactly what this looks like. Put the parentheses in there, do everything. So go 9 squared minus 17 squared, plus 17 squared, sorry about that, plus 17 squared minus 2, and then I put a parentheses around 9, a parentheses around 7. It's backwards, but you can see what I did. Times the cosine of 65. And again, just punch it in there. Again, backwards, but you can see what I did. And it equals. That is 316.75. Don't delete it, because we still have to take the square root of it. So hit second x squared, so the square root, and then hit the answer key, and you get the length of the side is equal to 17.8 units, whatever. Okay? Now that we know that 17.8, we could go ahead now and use the law of sine. Sine of 65 over 17.8 equals the sine of u over 17 to find angle u. And then we could find v just by figuring out what they add up to 180. So this is kind of that law of cosines, where you got to kind of have that side angle side or side thing kind of going on when you're doing this type of situation. Okay? Let's look at the next example. Okay, we'll kind of try it together with this one. So we've got triangle JKL. We know that J is lowercase j, so I'm going to draw this, of course. So there's J, there's K, there's L. Doesn't matter. Side J is 15, so the side opposite the J is 15. The side opposite the K is 13. And the side opposite the L is 12. It wants to find angle J. So we have to find this one. So we've got side going on. So we can go ahead and use the law of cosines. So the law of cosine says the measure of the angle that we're trying to find or that we're given. Okay, so in this case we have to find it. So that's 15. It's 15 squared is going to equal the other two sides added together and squared minus 2 times, in this case, 13 times 12 times the cosine. Well, we don't know this time, so it's got to be that cosine of j. So we have to do a little bit of manipulating now, kind of our formula. So I'm just going to I'm not going to figure anything out yet. I'm going to go 15 squared. I got to move the 13 squared to the other side. So minus 13 squared. I've got to move the 12 squared to the other side. So minus 12 squared. That's now going to equal negative 2 times 13 times 12 times the cosine of theta. So this is being multiplied by the cosine of theta. So to get rid of multiplication means I need to divide. So I'm going to divide this by negative 2 times 13 times 12. So I break out a calculator. I'm going to be very careful when you're doing this. So 15 squared minus 13 squared minus 12 squared. We do that and we get negative 88. It's not a bad thing to write that down. Over negative 2 times 13 times 12, which is negative 312. So that's going to be the cosine of theta. So we've got to find the measure of the angle. So you're going to go second cosine of the negatives cancel each other out. So I'm just going to go 88 divided by 312. And we get a measure of an angle of, doesn't really tell us what to do, measure the angle, 73.6 degrees. So now I know the measure of that angle is 73.6 degrees. Now, again, could we find angle K? Sure, we could find angle K, but now I wouldn't use the law of cosine. Again, it's a lot of work. I'd use the law of sine. So sine of 73.6 over 15 equals the sine of K over 13. Or the sine of 73.6 over 15 equals the sine of L over 12. Use the law of sine once you've already done it. Now, here's the thing. We created a different formula, essentially, right? We solved for cosine. So instead of doing all of this work every single time, wouldn't it be easier to come up with the formula for it? So let's think about our formula and what our formula could be if we're trying to find a missing angle. Okay, so the 15 squared really represents a squared. So that's going to be a squared. 13 and 12 represent b and c. So minus b squared minus c squared. All divided by negative 2 times b times c. That's going to equal your cosine, in this case, of A. All you have to keep in mind when you're doing this, okay, and this is the formula that you can use. This is essentially the law of cosine to find the measure of an angle. What you have to keep in mind when you're doing this is this letter and this letter have to be the same. So if you're trying to find angle A has to go first. So I was trying to find angle J, so J had to come first. If I was trying to find angle L, then it would have to be L squared and then the cosine of L sitting over here for those things. So just kind of keep that in mind. We'll do another couple examples, and we'll call it good for the day. Oh, we're back. Trying to drop you all over the place there for a second. Sorry about that. We're back. A little bit of, somebody came in, needed a little bit of help, so that was fun. Got to help somebody do some work on a Wednesday afternoon, which is always wonderful to do. So that's good. We're back now. So we're going to finish up Law of Sine and Law of Cosine. So the next one. You keep falling now. Stay down there. Anyway, so a wire. Let's move it over a little bit. Maybe that's the problem. A 3.5 meter long is attached to the top of a flagpole that leans to the left in a strong wind. A wire attached to the ground 1.2 meters to the right of the pole. A wire forms a 68-degree angle with the ground. What angle does the wire form with the top of the flagpole round to the nearest degree? So what is the angle? What angle does the wire form with the top of the flagpole? Okay, so what do we need to find? Looks like we need to find that right there. So we got to find the measure of that angle. Let's see. Looks like we got to do a couple things before we do that. We know we have to use the law of cosine. That's really our only choice right now because we've got side, angle, side. So we got to use the law of cosine. And when I use the law of cosine, it's going to give me the measure of this side right here. Then once we find the measure of that side right there, we can use the law of sine to find the measure of the angle up there. So let's go ahead. We've got the side, angle, and side, so we're just going to use the normal formula. We're going to find the blue. So we'll call it b. So b squared is going to equal 5.3 squared plus 1.2 squared minus 2 times 5.3 times 1.2 times the cosine of 68. So 5.3 on 5.3 squared plus 1.2 squared minus 2 times 5.3 parentheses 1.2 cosine of 68. So we get b squared equals 24.8. So we take the square root of that, and we get b is equal to, we'll just say 5, close enough to 5. So we'll say b is equal to 5. So now I know that this length is 5. Now that I know that that length is 5, I can use the law of sine. So we can do the sine of the angle that we know, 68 over the length of its opposite side, is going to equal the sine of the purple divided by 1.2. So we cross multiply. 1.2 times the sine of 68. That's going to equal 5 times the sine of p. So I'm just going to divide this by 5. And that will give me the sine of p. So 1.2 sine of 68 divided by 5 gives me a decimal. Then I have to do the inverse sine, so second sine. So the measure of that angle is, to the nearest degree, 13 degrees is where that one is. Okay, so again, a lot in there. We had to use the law of cosines not to get to the not the answer that we needed right away, but then we just built on it using the law of sines. Could we have used the law of cosine again? Yeah, you probably could have, but I wouldn't. Too much work. All right, the next one. It says a bike path follows a triangular path represented by triangle ABC. If A is the starting point and the measure of the angle at point B is 70 degrees, what is the measure of the angle formed by the path BC and CA? Okay, so again, it wants us to know the measure of that angle. Okay, again, we got to use that law of cosine first, and then use the law of sine. So we're going to find this side first. Once we find that side, then we can go ahead and use the law of sines. So x squared is going to equal 4 squared plus 2 squared minus 2 times 4 times 2 times the cosine of 70. So 4 squared plus 2 squared minus 2 times 4 times 2 times the cosine of 70. It's 14.5. Take the square root of that. X equals 3.8. So we've got the length of the side is 3.8. So we can use the law of sine. The sine of 70 over 3.8 equals the sine of c over 2. So it's going to be 2 times the sine of 70 divided by 3.8. 2 times the sine is 70 divided by 3.8. And then we need to do the inverse of that. So second sine, because we're in the law of sines now. And you get, does it tell us what measures? Doesn't tell us this time. So 29.6 degrees-ish, somewhere right in there, between 29 and 30 is the measure of that angle. Right? So again, we're going to do one more. In this case, figure out which one we need to use. Because remember, we've got 3 formulas now. We've got one law of sine and one law of cosine, depending on what you're trying to find. So we're going to go ahead and draw this first. So we've got triangle ABC. Gives us length A is 14, B is 12, and C is 5.8. It wants us to find the measure of angle A. So we have to find that down there. So I'm going to use that second formula, the A squared minus B squared minus C squared. So the angle that I have to find is A, so 14 has to go first. So 14 squared minus 12 squared minus 5.8 squared. All of that divided by negative 2 times 12 times 5.8. And that's going to be the cosine of A. And again, just make sure that this and this are the same. Well, not the same, but you know what I mean. That angle is opposite the side you're given. Okay, so 14 squared minus 12 squared minus 5.8 squared. 18.36 divided by, so 2 times 12 times 5.8. It's negative 13. That's negative 139. Let's try this again. Let's erase that. It's negative 139.2. So second cosine of 18.36 divided by negative 139.2 equals 97.6 degrees. Okay. Nothing wrong with that. We'll talk more about, when we start talking about the unit circles, we'll talk about negative cosines and all of those and where in fact that happens and why that happens when we're talking about unit circles tomorrow. So it's really a kind of a good one to end with, to say, negative cosines are okay. What happens with its negative cosine? Where's it located? We'll talk about that more tomorrow when we're talking about the unit circle. So just kind of a quick, the formulas again, law of sine, law of cosine formulas for you to take kind of a look at, and a couple of examples that they've done for you right down there. And then your assignment for tonight, page 431, kind of jumps around a little bit. 431, 20, 21, 26, 28, 29, 31, 32, 33, 34, 37. Okay. And that takes care of law of sine and law of cosine. We'll do the unit circle tomorrow. Hope everybody has a great day. We will see you next time.